Hi there students, we're going to continue with our chapter 3, chemical formula. Now for this part of the video we are going to cover empirical formula, molecular formula. We're going to go through chemical equations, how to form chemical formula, write down chemical equations, but we'll take it one step at a time. For this video I'd like to focus primarily on empirical formula and molecular formula. So first things first, we need to know the definitions. If you're not good at memorizing, don't worry about it. It's usually just 1 mark, but we need to understand the calculations. So let me just write down the definitions. Empirical formula. So empirical formula is the simplest whole number ratio of atoms of each element, and each element, because we normally have 2 to 3 elements, you'll see this in a bit, of each element present in the compound. Now on the other hand, molecular formula is the actual number of atoms of each element in the compound. So basically, what is the difference in terms of definition? Empirical is, this is the keyword, simplest whole number ratio. This is the word they are looking for. Whereas for molecular formula, the keyword is actual number. Now this may all seem a little difficult to take in, but don't worry. Let's look at calculations. Okay. Now as usual, I will read the question out. You guys write it down, think about it for a second, and then we solve. All right. So we're going to start with empirical formula, and in empirical formula what we need to do is we need to make a table. Okay, we are usually given 2 to 3 elements, usually 2. So the first thing we do is we write down the elements. In this case, for practice, we just use X and Y. These are the elements. Okay, the name of the elements could be magnesium, sodium, whatever. The next step is we need to get, remember the link guys, the link in chemistry, the number of moles. How do we get the number of moles? Let's think about this. Molar mass equals to mass over mole. So mole equals to mass over molar mass. Now in this question they usually give us the mass of each element. So to find the mole for each element, you just do mass over molar mass and mass over molar mass. You'll get the number of moles of each element. Here is the not to say tricky part, but something that the book doesn't really explain really well. What you have to do is to determine which has the lower number of moles. Let's say for example the number of moles of X is 0.1 and the number of moles of Y is 0.2. So obviously X has a smaller number of moles, right? Right. What we do is we take this number of moles and divide it by itself. 0.1 divided by 0.1. We do the same thing for this number of moles as well. 0.2 divided not by itself but by the smaller number 0.1. The reason we do this is because we want to get 1 on one side, okay, the number 1. So 0.1 divided by 0.1 is 1, 0.2 divided by 0.1 is, 1 second students, 0.2 divided by 0.1 is 2. Now that we have it in this form, we just write down the empirical formula based on these numbers. So the empirical formula will be x, the sub and the number associated to it will be the sub at the bottom. So x1, y2. We normally don't have to write 1 down. When you don't have a number, it's understood that it's 1. So we can just write this down as x, y, 2. Okay? Does this make sense, students? Let's now look at an actual example. So, 2.24 grams of iron combines chemically with 0.96 grams of oxygen to form an oxide. What is the empirical formula of the oxide? Okay, they've also given us the relative atomic masses of oxygen 16 and the relative atomic mass of iron 56. So first step, we write down both the elements, iron, which is Fe, and oxygen, which is O. Now we have the mass of iron, yes, 2.24 grams. Do we have the mass of oxygen? Yes, 0.96 grams. Now, what is the next step, students? We need to find the number of moles of iron and oxygen. So let's see. Molar mass equals to mass over mole. So mole equals to mass over molar mass. We have the mass of iron to be 2.24 divided by the molar mass of iron, which is 56. 2.24 over 56 is equal to 0.04 mole. What about for oxygen? Mass is 0.96 divided by molar mass of oxygen is 16. We get 0.06 mole. Now, next step, which of the two numbers is smaller? Obviously 0.04 moles, right? So we divide this by 0.04 and we also divide 0.06 by 0.04. 0.04 divided by 0.04 is 1. 0.06 divided by 0.04 is 1.5. Now this happens a lot. We don't want a decimal number. We can't have a decimal number. So in order to get rid of this decimal number, we have to multiply both these numbers by another number to get whole numbers. So if I multiply 1 times 1, I still get 1. 1.5 times 1, I still get 1. Let me pick a bigger number. I multiply both these numbers by 2. 1 times 2 is 2. 1.5 times 2 is 3. There we go. We now have whole numbers. So 1 times 2 is 2. 1.5 times 2 is 3. We've got whole numbers. Everything is settled. We just need to write down the empirical formula based on these numbers. So empirical formula is Fe sub will be 2, O, and the number below 3. This is your empirical formula. So simple, right guys? Right. Let's do more examples to reinforce your understanding. There are also some questions for empirical formula where they give you a percentage. They don't give you the mass, they give you the percentage, but don't worry, it works almost the same way. So when you have a percentage, guys, let me give you some elements. X and Y, for example, okay, and I tell you that X has a percentage of 40%. I'll just write down that percent, 40%. and I don't give you the percentage of y. Always remember guys, the total percentage must be 100. So if x is 40%, y will automatically be 100 minus 40, which is 60%. Now treat these percentages as masses. Imagine 40% is 40 grams. So we just write down this as 40 grams. We write this down as 60 grams. Can we get the number of moles? Yes, mass over molar mass. So whatever the molar mass of X is, 40 divided by that molar mass, we get the number of mole. 60 divided by the molar mass of Y, we get the number of mole. Whichever is the smaller number, we divide it by that. This will also be divided by the smaller number of moles. Same thing, right guys? Right. Let's do an example. A potassium compound has a percentage composition as the following: K 31.84%, Cl 28.98%, and the last one is oxygen, which is 39.18%. Let's add these up, students. 31.84 plus 28.98 plus 39.18. Do we get 100%? Yes, we do. So now what does the question want? What is the empirical formula of the potassium compound? And they gave us the relative atomic masses of oxygen, of potassium and chlorine. So let's see, relative atomic mass of oxygen is 16, relative atomic mass of potassium is 39, relative atomic mass of chlorine is 35.5. Even if they don't give this to you guys, you know what relative atomic mass is, right? Nucleon number. You can get it from the periodic table. It's the number on top of the element. Good. So let's start this, okay? Make the table, write each element down. K, Cl and O. K has a percentage of 31.84%. Cl has a percentage of 28.98%. And O has a percentage of 39.18%. So now remember students, we pretend that these percentages are grams. So 31.84 grams, 28.98 grams and 39.18 grams. Now how do we find what do we do next? We have the grams, we need to find the link, always the link, the number of moles. Number of moles is mass over molar mass, so 31.84 divided by the molar mass of potassium, which is 39, you get 0.816. How do we get the number of moles for chlorine? 28.98 over 35.5, you get 0.816. How do we get the number of moles for oxygen? 39.18 divided by 16, which is equal to 2.449. Next step, we divide all three by the smallest number of moles. What is the smallest number? 0.816. So automatically 0.816 divided by 0.816 is 1. 0.816 divided by 0.816 is 1. 2.449 divided by 0.816 is 3. So now we have our three numbers. They are not in a decimal, they are whole numbers. Can we write the empirical formula? Of course. K, the sub is 1, so we don't have to write that. Cl, the number is 1, we don't have to write that. O, 3. This is your empirical formula, students. Now, going to do one last empirical formula question for you guys. After that, it's going to be time for molecular mass, okay? Or would you guys rather have me do 2 questions? Let's do one lah. Let's move on after that to molecular formula, okay? You guys are becoming experts at this already. So, next question. Copper 2 iodide. Copper 2 iodide is written like this. Copper 2 iodide. And how to form the chemical formula and things like that, we'll come to that. Chill guys, let's do this, okay? Copper 2 iodide contains 20.13% of copper by mass. Find its empirical formula. So, I have copper, I have iodine. Okay, I have the percentage of copper, which is 20.13%. Do I have the percentage of iodine? They didn't give it to me in the question. What do I do? Wait a second guys. Remember I told you that copper and iodine, the total will have to equal 100. Whenever you have at like 2 or 3 elements, the sum of percentages must equal to 100. So if copper is 20.13, iodine will be 100 minus 20.13, which is 79.87%. We now treat these as grams. So same steps guys, same steps. 20.13 grams, 79.87 grams. Can we find now the number of moles? Yes, mass over molar mass. What is the molar mass of copper? 64 grams per mole. What is the molar mass of iodine? 127, given in the question. So 20.13 divided by 64 is 0.315. 79.87 divided by 127 is 0.629, which is a smaller number, 0.315. So 0.315 divided by 0.315 is 1. 0.629 divided by 0.315 is 2. That's it guys. Can we get the empirical formula? Of course. Cu, we don't write the 1 down, I, 2. This is your empirical formula guys. Congratulations. Now, another important question that they like to ask for empirical formula is based on the 2 experiments guys. Now, if you look at your Buku Rujukan, you can, under chapter 3, you will see something that says determining the empirical formula of copper 2 oxide and determining the empirical formula of magnesium oxide. Don't worry about these 2, we'll focus on them in a separate video, okay? I'm going to go ahead and now talk about molecular formula, but I will come back to these 2 experiments. So let's do this guys. Molecular formula. What is molecular formula? We know the definition, we wrote it down just now. Actual number of atoms, in an element of a compound, right? So that's the definition, but we don't understand how it works. The basics of molecular formula is really simple guys. What we are given, we are always given a simplified formula like an empirical formula. So example, say X, Y, 2, okay, where X is an element, example sodium, carbon, anything, and Y is also an element, chlorine, iodine, anything, and we have this 2 here. Now the question will give us the total molecular mass of these 2, okay. Say the molecular mass is, or the molar mass, you can use either word, is equal to say 100, okay. Now we know the individual relative atomic mass of X and Y from the periodic table. Say the molecular mass of X is 25, and let's say wait, let me think for a second guys. Okay, let's say the relative molecular mass of X is 40 and the relative molecular mass of Y is 30. So what we're going to do is we're going to add these two molecular masses. So 40 plus, we have a 2 here, 2 times 30, and all this times x. X is a factor. Okay, we'll see what happens, equals to the total molecular mass, which is 100. 40 plus 60 is 100. 100 times x is 100. X equals to 100. So what is the value of the factor? X equals to 100 divided by 100, which is 1. This 1 is multiplied to both the numbers here. We have x1 and y2. So our molecular mass will be x, 1 times 1 is 1, and then y, 2 times 1 is 2. It's the same. Whenever the factor is 1, you will end up getting the same formula as this. If the factor was 3, for example, you would get x3, y6. If the factor was 5, you would get x5, y10. You see the logic, guys? So we have to find the factor, and you'll be good to go. So let's look at some examples, okay? Students, just give me a second. I need to get my charger. I'll be back in 20 seconds, okay? Students, I'm back. Sorry about the delay. Let me just connect my phone to my charger. Okay. So, we're talking about molecular formula. We're going to do an example now. We understand how it works. Let's test our knowledge. Question is, a carbon compound has an empirical formula of CH2. So, CH2 and a relative molecular mass of 70. So they're already telling you the molecular mass of this is 70. Find the molecular formula of the compound. We have the molecular mass. This is carbon, this is hydrogen. So we follow the same steps, guys. What is the relative atomic mass of carbon? Relative atomic mass of carbon is 12. Relative atomic mass of hydrogen is 1. So we write down 12 plus a 2, because we have a 2 in front of the hydrogen or below the hydrogen. 2 times the atomic mass of hydrogen is 1. All this multiplied by the factor. Remember the factor, guys? Factor, let's call it x, equals to 70. So we do this step by step. 12 plus 2 is 14. 14 times x is 14x equals to 70. What is the factor? X equals to 70 divided by 14, which is 5. So now we have the value of the factor. We multiply that with each number at the bottom of each element. So we have C1H2. So we end up getting C5H 2 times 5, which is H10. This is our molecular formula, students. Does this make sense? Let's do another one, students. So I'll read the question out. Get ready. 8.5 grams of hydrogen peroxide. Now hydrogen peroxide comprises of hydrogen and oxygen. Okay, so back to the question. 8.5 grams of hydrogen peroxide contains 0.5 grams of hydrogen. If the molar mass of hydrogen peroxide is 34 grams per mole, find its molecular formula. So we are given H and O, hydrogen peroxide. We are given the mass of hydrogen. Are we given the mass of oxygen? No, but we are told that the total mass of hydrogen plus oxygen is 8.5. So to find the mass of oxygen, you get the total mass 8.5 minus the mass of hydrogen, which is 0.5. You get the mass of oxygen to be 8. So H 0.5 grams and O 8 grams. Excuse me, students. Now the question is asking for the molecular formula, but we don't even have an empirical formula. Remember in the previous question, guys, they gave us the empirical formula. We had to find the factor, things like that, right? Now we are finding the molecular formula without even having the empirical formula. We just have the mass of each element. So the steps are, think about it. First we get the empirical formula, then we get the molecular formula. Okay, let's do this together, guys. So H and O. Okay, H is 0.5 grams, oxygen is 8 grams. Can I get the number of moles of hydrogen? Yes, 0.5 divided by the molar mass of hydrogen, which is 1. So I get 0.5 mole. Can I get the number of moles of oxygen? Yes, 8 grams divided by the molar mass of oxygen, which is 16. 8 divided by 16 is 0.5 moles. Both these numbers are the same. So the smallest is the same, 0.5. 0.5 divided by 0.5 is 1. 0.5 divided by 0.5 is 1. So we now have the empirical formula to be HO. Now, what do we do from here, students? We are given the molar mass of HO to be 34, right? That's what the question said. This is the total. So, how do we find molecular mass? Individual relative atomic masses. Hydrogen's relative atomic mass is 1. Oxygen's relative atomic mass is 16. So, we add them. 1 plus 16 multiplied by the factor. Remember, molecular mass is all about factor, equals to 34. 16 plus 1 is 17. 17 times x is 17x equals to 34. X is equals to 34 divided by 17, which is 2. Now we multiply this factor with each number here. Fortunately, both numbers are 1 and 1. So our molecular formula will be H2O2. You see how easy this is, guys? There is some thinking. You know, you have to do empirical to get molecular. In this case, in the previous case, we didn't have to do this. But at the end of the day, it's all the same thing. And once you get so good at it, it comes naturally. It becomes so easy. So one last question I'm going to do, guys, is called percentage by mass. What does percentage by mass mean? What is a percentage in the first, before we even answer this question, we need to understand what is percentage. So a percentage is a number divided by the total value times 100. Okay, so if I say that John took an exam, his score was 90 out of 180. So what is John's percentage? John's percentage is the number which is 90 over the total score, which is 180, times 100, which is 50%. We use the same logic to do percentage by mass. So, give you a quick question. Calculate the percentage of potassium by mass in potassium carbonate. Now, we need to know what is the molecular formula of potassium carbonate, and we haven't learned how to determine that yet, so I'll just write it down for now. Potassium carbonate is K2CO3. We want to find the percentage of potassium in this whole compound. We need to know the molecular formulas of potassium, carbon and oxygen. Potassium is 39, carbon is 12, oxygen is 16. So we just want to find potassium. So potassium over the total compound, which is potassium carbonate, times 100 will give us the percentage of potassium by mass. What is the percentage, what is the value for potassium? 39, but we have a 2 here. So 39 times 2, which is 78, over, what is the total molecular mass? 39 times 2 plus carbon is just 1, so 12, plus oxygen, which is 16, times 3. So we end up getting 78 over 138, right? 78 plus 12 is 90, 90 plus 48, 138, times 100%. What do we get, students? 56.52%. This is your percentage by mass, or percentage of potassium by mass. How would I find the percentage of carbon by mass? Same thing, students. Carbon is 12 over the total, which is, the total is going to be the same, 138, times 100%. And you end up getting, let's see, 12 over 138 times 100 is 8.69 or 8.7% percentage of mass for carbon. What about for oxygen? Oxygen is 16 times 3, 48. So 48 over 138, which is the total, times 100%, which equals to 48 over 138 times 100, 34.78%. So you get the idea, right, students? Very easy, very easy. So we're done with empirical formula. We know how to deal with the mass. If they give us percentages, we just convert those percentages into mass, right? Do the same thing. Molecular formula, we know we have to find the factor, and we know how to do percentage by mass. So we're good to go. In the next video, I'm going to show you guys how to make chemical formulas. This is so important. If you don't know how to make chemical formulas, that's it, guys. So please understand and focus the next video to the best of your ability. Okay, guys? See you there. Thank you. Bye.